Okay, so today we'll start with naming alkanes, naming them in an unbranched way, and then naming the branched alkane. Just keep in mind that alkane are part of aliphatics that are bonding carbon and hydrogen, and when they are single bonded, carbons are single bonded between each other, are known as alkane. So this one here means that carbons is single bonded. And then we'll see the other one when at least one of them is double bonded or triple bonded, which belongs to alkane and alkyne. So we'll start with the single bonded. The general formula for alkane is CnH2n plus 2. So if n, where n is a whole number, if n is 2, then we'll have C2, then we'll have 2 times 2 plus 2. So we'll have a molecular formula of C2H4. Or if N is 4, let's say, C4, then hydrogen will be 2 times 4 plus 2, which will be C4H10, a formula of butane, which we saw it into the 6. This should be 6. Sorry, we saw it in the previous video. Okay, so now let's see how can we name butanes. I will stop the video and draw a table here so that you have this table in your data booklet and then use it for your practice. The more you practice, the better you will become to them. Okay, so the table that I want you to replicate into your data booklet is something like this. On the first column, we have the number of carbons. On the second column, we have the stem prefix, which will serve us even later on. So this is very important, even when we are working with branched alkane. Molecular formula, the name, and the line structure. So when we have the first one is completed, when we have one carbon, it's known as methane. Meth is the stem prefix. A molecular formula based on that general formula that we just said, CnH2n plus 2 will be CH4. And then the name is methane, so it is the stem prefix added an A-N-E. And the line structure is like that. When we have 2 carbons, then the name, the stem prefix is F, and we will use those prefixes even later on when we are doing branches. Then the molecular formula will be C2, and H2 times 2, 4 plus 2 is 6. Okay, and the name is F, that is the stem prefix, ane, that is the suffix that it takes when we are dealing with alkane. And the structural formula is something like this: C 1, 2, 3, 4, 5. I will do different formulas sometimes, simplified structural formula sometimes. The third one, the stem prefix for it is prop. Every time that you see 3 carbon, then you will say prop with the whatever suffix is it? C3H, 3 times 2 is 6, plus 2 is 8, and the name is propane. Prop, that is the stem prefix, ane. The structure will be carbon, 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 and then tick, 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 tick for hydrogen. The fourth one will be bute, and the formula is C4H. 2 times 4 is 8, plus 2 is 10. Butane, butane. And the line, if we are drawing the line structure, will be something like this: 1, 2, 3, 4. Okay. Next one is 5, when we have 5 carbon. And on that case is pent. The formula is C5H. 5 times 2 is 10, plus 2 is 12. And pentane. The line structure will be 1, 2, 3, 4, 5 carbons. When we have 6, then it is hex. Let's see, 6H, 6 times 2 is 12, plus 2 is 14, and it is hexane. The structure is C, and then H, 2, 3, 4, 5, and 6. So H. Okay, now move to 7, 8, and 10. Seven carbons means that the stem prefix is hept. Let's see, 7H1416. Name is heptane. And the structure will be something like this: 1, 2, 3, 4, 5, 6, 7. Next one is 8. And you guess it is oct. So will be C8H16 plus 2, 18. And it is octane. And you know now what is the structural or the condensed formula, molecular formula, expanded molecular formula will be H CH3 CH2 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 1 2 3 4 CH2 CH2 one more CH2 and CH3. This is expanded condensed structural formula. For 9 we'll have none and C9H1820, and non-ane, and will be C3, 4, 5, 6, 7, 8, 9, and then ticks here for the hydrogen. Okay, and the last one is 10, 10, and for 10 is deck, so C10H22, and it is decane, and you get now what is the structure. I want you to have a picture like this, especially with the 1, 2, 3, 4, the three, the four columns, because you will do so much of the other one, so that this will become as a second nature to you. But a picture like this will help you to have handy in your data booklet, in one of those pages that you have as a taking notes in your data booklet, so that when you practice, then you those are becoming more familiar with you. What is important is the second one and the connection with the first column, so this one here, and the connection of it with the first column, because we'll use those steam prefixes even when we are using branched, when we are naming branched of anything. Okay. So now let's take a look at the branched alkane. Let's suppose that we have a normal alkane. So let's suppose that we have this as the condensed structural formula of the alkane. CH3, CH2, 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 and CH3. So 1, 2, 3, 4, 5 carbons means that we are pentane. Okay, when we have a normal non-branched alkane, then this will be named as pentane. Okay, the molecular formula of it will be C5H12. Okay, good. The structural formula, the full structural formula of this will be 1, 2, 3, 4, 5, and then ticks here for hydrogen, which you may not write them. However, let's see now what will happen when we have branched one. So let's suppose that we have now, again, 5 carbons, but carbon, carbon, carbon. Here we have a carbon, methane, and here we have CH3. So again, we have 5 carbons, hydrogen, 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 hydrogen. We have 5 carbons here, and we have 3 and 3, 6, 7, 8, 9, 10, 11, 12. Okay, which is the same as the molecular formula C5H12. So this is known as the branched or isomer of alkane. In order to name the branched the branched alkane, what we will do is first we'll find the longest chain, carbon chain. So we will see where the carbon is not disconnected. I will use a lot of colors here. So this will be the longest chain. Okay, identify. The second step will be name the carbons, number, not name, number the carbon atoms starting at the end closest to the branch. That is the closest one to the branch. So on this case, we can start 1, 2, 3, or 1, 2, 3, and then the branches that we see are those two. Those two are the branches. So in this case, doesn't really matter how we start because always 2 will be where the branches are in both ways, from left to right or from right to left. So it doesn't quite really matter. And now branches, branches ends with YL, and then alkane are with ANE. Branches and with YL. So those stem prefixes that I told you, the second column here, meth, eth, prop, but, but, pent, hex, hept, oct, non, and dec. If they are branches, then we'll end with YL. So will be methyl, ethyl, okay, propyl, decyl, okay, when they are branches. And when they are in the structure, when we are talking about alkane, ends with ANE. Okay. First, name the branches. Name the branches. Starting with the place on the carbon chain. So 2, 3, 4, 5 on the carbon chain. And then the branches. The branches are listed in alphabetical order. So not from left to right, not from the closest to the number 2, the lowest, but alphabetical order. In alphabet. Okay, let's see, because it sounds that it is too much. Let's see. Let's suppose that we have this CH3, CH, And then here we have CH3 and CH3. So now the longest chain is, you can say this one here, or you can say this one here. Chain doesn't have to be straight. They are all three, so chain doesn't have to be straight. Okay, I will keep this one here for simplicity. And then you start numbering carbons in the longest chain. 1, 2, 3, or 1, 2, 3. This one here is the branch. If this is the parent or the longest chain, then this is the branch. The branch, any way that you label the chain, either from left to right or from right to left, is on the second place. So it doesn't really matter which way are you labeling it. Now, we'll start. The name of this branched or isomer of alkane will be the place in which the branch is at. 2, comma, sorry, no comma, there is only one, comma, the branch is with one carbon. One carbon have a steam prefix of meth. So meth, to identify that is a branch, we will go YL, and then we have 1, 2, 3, and the stem for 3 is prop. To identify that we are dealing with alkane is propane. This is how we will name it. Okay, we'll start with the branch location. The branch name. How many carbon do you have on that branch? Followed by YL to identify that as a branch. And then prop is the name of parent chain, let's say. Okay. We'll see some more examples now. Make sense? We'll see some more examples. So this is the structure that we have. Let's count now which one, identify first which one is the longest carbon chain. So we can go, the longest chain, it's no, it is that if you are moving, you are not lifting your pen. So you are going from one point to the other without lifting the pen. So I will do it with like a marker so that you can see. So if I'm going straight, this is the first attempt, or the first, let's say, way that we move. So then we count 1, 2, 3, 4, 5. Okay. Now let's take a look at a different way of moving. Okay. So let's see now. I can move 1, 2, 3, 4, 5. Those two are the same. However, so five is the number of carbons in that chain. However, if I move in a different way, 1, 2, 3, 4, 5, 6, then I have a chain that is longest. So therefore, the longest chain will be the chain on the red. So I will erase those two. Okay. Now let's identify the branches. Okay, let's see which one is a branch and what is the name of that branch. So one branch is this one here, and one branch is this one here. So branches are like branches of the tree. Okay, this is the trunk of the tree, and now those are the branches. As you see, those two branches are the same, have one carbon based on the stem prefix. The branch is named as meth because it is one methyl to identify that there are branches. Okay, now let's start counting. So if we start counting this way, 1, 2, 3, 4, 5, 6, then the first branch is on the 3. And if we start counting in a different way, in an opposite way, 1, 2, 3, 4, 5, 6. The first branch is on the third way. So that means that it doesn't matter which way you are moving, you are having the same result. Now let's name it. So we'll start with the branch location. We have one branch on the third place, and one branch on the fourth place, one on the third and one on the fourth. Okay, then a dash line. Now we have two branches of the same. So when we have 2 or 3, then we use die or 3 to identify that we have of the same. Okay, the same prefixes that we are using in a regular school, in a regular chemistry. Okay, so now we have di, 2, methyl, to di, methyl. We are done with branches by identifying the branch locations. Branch locations on the third and the fourth place, telling that we have 2 of the same and the same is methyl, meth, or one carbon. And now we'll end with the parent chain. Okay, the parent, since we have 6, 6 has a stem prefix of hex. Since we are dealing with single bonded, meaning alkane, then will be alkane. So this will be the name of this structure that you see. 3,4 dash dimethyl hexane. Let's suppose that we have this, and I think this will be the last one for alkenes as an example on the video. So first let's identify the longest chain. So we start 1, 2, 3, 4, 5, 6, 7. This is the longest one. Or 1, 2, 3, 4, 5, 6, not. 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 Okay, so the longest chain is this one here. Okay, let's identify the branches. We have one branch here, one branch here, one branch here, and one branch here. So this is kind of obvious that we will start counting from this place because the first closest branch is here. It's this methane that we have here. So 1, 2, 3, 4, 5, 6, 7. Now, let's name the branches, okay? So those two branches have one carbon, are methyl. Those two branches have two carbons, and they are ethyl. This is why I thought that it's important to know and to remember the stem prefixes that are on that column that I gave you. Okay, now let's start. M is after E. So when you alphabetically, E is before M. So now let's start. When we are starting, we are starting with branch allocation that alphabetically is first. So it is on the fourth place, correct? It's on the fourth place here. So it will be 4, comma, 4, because we all have 2 on the same place. Di, because you have 2 of the same. Ethyl, okay. Then you're moving to the second branch. 2, comma, 3 on the second place and on the third place. Di, because you have 2 of the same. Methyl, you're done with branches, and now you have 7 carbons. Hapt for 7, and ane for alkane. That is the name of this compound. And with this example, we will conclude this video, and we will do more examples in class.